Hi everyone, so this is a fractions lesson on reciprocals, and what we're going to do first is we're going to find the reciprocal of each number below. So we're going to start off with just some standard fractions. So to find the reciprocal of a fraction, it's really easy. The reciprocal of 1/8 is 8/1, which is 8. So to find the reciprocal of a fraction, you simply switch the numerator and denominator around. And then if you can simplify, so here we could simplify. So we got the number 8. So for 3/8, it's actually going to be even easier. The reciprocal of 3/8 is going to be 8/3. I've just switched my numerator and denominator around. And for 11/8, even though this is an improper fraction, it's exactly the same thing. We're just going to switch the position of the numerator and denominator. Notice I'm not writing this. So for the question 11/8, I'm not writing equals 11/8. I'm not writing equals 8/11. A number and its reciprocal are not equal to each other, so I shouldn't be writing equals 8, equals 8/3, equals 8/11, because 1/8 is not equal to 8. 1/8 is a very small number and 8 is a larger number. So that's why I'm writing reciprocal equals. So we need to make sure we don't do that. A few special cases, or slightly less quick questions, are if we're given a mixed number. To find the reciprocal of a mixed number, we first need to change it into an improper fraction, and then we just do the same thing. So changing this into an improper fraction, I have 2 multiplied by 8 is 16, plus 3 is 19. So I have 19/8 as my mixed number, as my improper fraction. So now I can do my reciprocal just by switching the position of the numerator and denominator, 8/19. If we are given an integer, then we need to change that integer into a fraction. So we know that any whole number is equal to whatever it is over 1. 3 divided by 1 equals 3, so that makes sense. And now the reciprocal is really simple. The reciprocal of 3 would be flipping 3/1, which would be 1/3. So the reciprocal of 3 is 1/3, and the reciprocal of 8 is 1/8. So there's a little bit of a pattern there. With decimals, we need to change them into fractions first. Now, for 0.2, you might know immediately what fraction this is, but I'm going to show you how to go just from the decimal itself. So I'm going to do the same thing that I did here. I'm going to put this over 1 to start with. And then, because I shouldn't have a decimal in a fraction, I'm going to multiply by 10 to get this into 2/10, and then I'll simplify that to get myself 1/5. So 0.2 is equal to 1/5 as a simplified fraction. And then the reciprocal here, maybe if you've spotted the pattern from the previous one, the reciprocal of 1/5, well, I'm going to flip and get 5/1, and 5/1 simplifies to just 5. Now, you might be thinking, why do I need to know what reciprocals are, and why is it important to learn how to find one. And we'll talk about that next, why they're useful. Just before we talk about the most useful way to use reciprocals, is just to cover this fact here, that a number multiplied by its reciprocal will always equal 1. So over here we have found some pairs of reciprocals, right? So we were given the number 0.2 and we found that its reciprocal is 5, and 0.2 multiplied by 5 equals 1. The same for, maybe let me go to a pair up here. We had 11 over 8 and 8 over 11. So we had 11 over 8. And if I multiply it by its reciprocal, which would be 8 over 11, then I do get 1. Because I would get 11 times by 8 is 88, and 8 times by 11 is 88, and 88 divided by 88 is 11. So that's one fact that we need to know about reciprocals. But where they come in really, really useful is when we have to multiply or divide by fractions. So I guess another fact that we can bear in mind is that if I multiply by a number, that is exactly the same, so that's equal to dividing by its reciprocal. So if I had a question like 20 multiplied by, I don't know, by a quarter, you might be thinking, oh, that's quite hard. Or maybe not that that's hard, but you might be thinking, I can use reciprocals to make this a little bit easier for myself, because multiplying by a number is the same as dividing by its reciprocal. So instead of doing 20 multiplied by a quarter, I can do 20. In fact, I'm not even going to use an arrow here. I'm going to use an equal sign because these two calculations are equal. I can do 20 divided by the reciprocal of a quarter, which is 4. And then 20 divided by 4 is nice and quick for us to do, is 5. So this is where reciprocals come in useful. 20 multiplied by a quarter is exactly the same as 20 divided by the reciprocal, divided by 4. And that's equal to 5. You know, you can even do this with decimals. So, you know, over here, we found that the reciprocal of 0.2 was 5. So if I had to do 20 divided by 0.2, you might be thinking, oh, okay, I can use my methods that I've learned, where I do 20 over 0.2 and then I multiply to get 200 over, and so on and so on. You could use that method, there's nothing wrong with it, but with reciprocals, we could say, well, actually, this is equivalent to dividing by a number is the same as multiplying by its reciprocal. And the reciprocal of 0.2 is 5. And 20 multiplied by 5 gives us 100. And this little fact helps us to understand why the really commonly known rule that we learn when we divide fractions, which is keep, change, flip, this rule comes from the fact that we just spoke about. So when you learn to divide with fractions, so if I just create a question here, 4/5 divided by 2/3, for example, we would do keep, change, flip, right? So we would keep the first fraction the same, and then we change the divide to a multiply, and we flip the fraction. And this is the same as what we were doing above. We had to divide by a number, and we ended up multiplying by its reciprocal, because flipping 2/3 is the reciprocal 3/2. So that's why the rule keep, change, flip works, because you use reciprocals, and you use the fact that if I divide by a number, that's equivalent to the same as multiplying by the reciprocal, or if I multiply by a number, that's the same as dividing by the reciprocal. So that's just why reciprocals are really useful to know about.